Hey everyone, welcome to another Explainer. I am absolutely thrilled to have you here today. We're embarking on a super fascinating investigation into what might honestly be the most misunderstood information technology in all of human history. We are traveling back in time to the majestic heights of the Andes to uncover a lost system of data storage that was literally centuries ahead of its time. We're talking about the Quipu, the secret knotted code of the mighty Inca Empire. So let's just dive right in. Now, for a second, I want you to step into the shoes of a linguistic anthropologist analyzing ancient Andean information technologies. Just ask yourself, what if everything we know about the history of writing is entirely wrong? For centuries, Western historians completely dismissed the Inca Empire as an illiterate civilization. Think about that. This was a massive, highly sophisticated Bronze Age empire of 10 million people, yet it supposedly lacked any system of writing simply because, well, they didn't carve alphabets into stone or ink them onto paper. But honestly, that's a massive bias. We are going to completely shatter that preconceived notion today, because the Inca weren't illiterate. No way. They were just writing in a dimension we weren't even looking at. And this right here brilliantly illustrates the exact paradigm shift we need to make. Just look at standard 2D alphabetic scripts, like the English we're reading every day. It's flat, it's strictly visual, and it runs straight in a line. But the Quipu, it operated in an entirely different dimension. It had this 3D tactile syntax that actually demanded a highly trained official, known as a Quipu Kamayok, the folks responsible for maintaining these sacred and bureaucratic records, to use both their sight and their sense of touch to read it. To really contrast the topological nature of Quipu knots with our traditional flat scripts, we have to grasp its branching data structure. The physical string wasn't just holding the text, the medium literally was the message. Okay, so let's break down the actual structural components of the Quipu. Notice that thick horizontal cord running right across the top. That's your primary cord. Hanging directly from it, you've got the pendant cords stretching downward. And then, branching off from those pendants are the subsidiary cords. Notice how this mimics a really complex tree-like hierarchy? It's like a giant puzzle. This wasn't just some random tangle of strings. It was a highly structured, organized framework designed to hold immense, and I mean immense, amounts of information. Let's move on to the physical variables and see how this builds a true sensory language. See, the physical act of touching these knots and threads was absolutely crucial. It helped Inca officials actually recall complex data. A Quipu Kamiok didn't just look at the cords, they physically felt them. Take the fiber type, for instance. They used cotton, alpaca, vicuña. They even used human hair. And every single choice carried a highly specific encoded meaning. For example, incorporating human hair often signified specific social status or recorded things like the diets of commoners in Andean communities, which, differed from the elite. From the direction the thread was twisted, to whether it was attached to the front or back of the main cord, to the incredibly nuanced color coding using 24 distinct hues, every single element was a variable in an intricate code. So you might be wondering, how did they actually use these cords to count? Well, the Inca relied on a brilliant base 10 mathematical logic. The physical position of the knot on the cord determined its exact value, very much like our decimal system today. The knots at the very bottom are long knots, and those represent the ones column. Moving up the cord, you find overhand knots representing the tens, then the hundreds, and so on up the line. But here is the true stroke of genius, seriously. The deliberate absence of a knot represents zero. They physically engineered the mathematical concept of zero just by using empty space on a string. How cool is that? And they used this incredible math to run an entire empire. We can actually anchor this ancient tech to modern concepts by looking at the Pirachuco archive. There, archaeologists discovered that Quipu data hierarchies perfectly mirror contemporary relational database architecture and data synthesis. It's wild. At step 1, local officials recorded primary data, like local farming output or tax obligations on level 1 Quipus. At step 2, these were summed up into level 2 regional summaries. And finally, at step 3, all that data was aggregated into level 3 Quipus and sent straight to the imperial capital in Cuzco. They synthesized a massive administrative and tax infrastructure from local villages all the way up to the emperor, without a single drop of ink. Part 1. The Epiphany. From Numbers to Narratives. For a long time, we thought Quipus were strictly mathematical, but recent discoveries have sparked a massive epiphany. The Inca were actually using knots to write stories. Let's look at how this tactile storytelling actually worked. The physical choice of materials functioned as a logosyllabic writing system. So, using fine vicuña fiber might indicate high-frequency phonetic sounds, while using deer hair could act as a logogram marking a non-numerical story about, say, a conflict. And the way a cord was attached, whether it was front-facing or back-facing, literally encoded a person's social status. It wove upper Hanan or lower Huron moiety affiliations directly into the cord hierarchy. They were combining colors and animal fibers to record individual names and events. It's a completely tactile communication method that absolutely rivals the complexity of standard graphic writing systems. Now, what's the significance of the number 7 here? Well, researchers have found that the Quipu relied heavily on binary logic. Remember those S-twist and Z-twist thread directions we mentioned earlier? Those functioned exactly like early data bits, just like modern computational zeros and ones. By combining these binary choices, spin direction, attachment direction, ply direction, the Inca were able to aggregate data into complex 7-bit chunks. They literally built a binary database entirely out of knotted string. Which brings us to the real technological climax of our detective story. Because the Quipu operates on binary logic and structured variables, modern data scientists can actually digitize them. These tactile string variables are being translated directly into modern spreadsheets by projects like the Harvard Quipu database. They're meticulously logging the spin, the ply, the attachment direction, and the color into columns and rows. We have officially shifted away from simple mnemonic theories about memory beads right into complex data science methodologies. And because these archival records are now digitized, we can unleash modern computational tools on them. Researchers today are applying machine learning to hunt for hidden syntactic patterns within these digitized core datasets. They're using unsupervised AI models, which are algorithms designed to find hidden patterns in data without a pre-existing key, to help isolate specific, unknown phonetic markers in the narrative strings. Basically, they're mathematically searching for the Incas' lost language without even needing a Rosetta Stone. It is an incredible, high-tech treasure hunt. But despite all this incredible technology, we face a pretty heartbreaking bottleneck: 1,400. That is the maximum estimated number of intact pre-Columbian Quipus that survive in the world today. Think about it. Out of an empire that managed millions of citizens over several centuries, this tiny number is all we have left. So why are there so few? Well, following the Spanish conquest, colonial authorities quickly realized the sheer bureaucratic and administrative power of the Quipu. As historical records note, those authorities explicitly ordered the destruction of these unique information tools, viewing them as dangerous tools of resistance and idolatry. By burning the cords and disrupting the Quipucama yokes, the only people who could fully read them, colonial forces literally cut the cord on centuries of cultural memory and administrative genius. Which leaves us with this final, really provocative thought. If a so-called illiterate Bronze Age empire could engineer a sophisticated 7-bit binary database entirely out of knotted string, what other ancient, supposedly primitive technologies are out there just waiting for the right modern algorithm to decode them? The Quipu challenges our very definition of what technology and writing can be. It proves that human ingenuity isn't strictly linear. Sometimes it's a deeply complex, beautifully woven knot. Thanks so much for joining me on this explainer, and I hope this leaves you eager to explore more of our hidden human history.